This video will show how Peplink and Pepwave Speedfusion tunnels can be created. We're going to demonstrate for you how to create a basic tunnel. We'll show how easy it is to add bonding. Then we're going to show some troubleshooting steps that you can take when things aren't working as expected. And lastly, we'll show how the logs and status screens can help with this troubleshooting. In order to do this, I've created a simple lab environment which will allow us to easily show how this works. We have a Fusion hub running on VMware, which is able to get out to the internet via an automatic firewall. Then there's a Pepwave HD4 MBX, which will be given a single 35 meg WAN connection and is directly routable to the Fusion hub due to them being on the same layer 2 network. We'll create a tunnel between the Fusion hub and the MBX in the first instance. Moving on from that, we'll add a second 35 meg connection to show how easy it is to bring bonding to the solution. Finally, we will add a cellular connection to the device. This will mean that the tunnel has to be connected to the Fusion hub via the firewall, and we will talk about the steps that are required to make that work. So these are the two devices that are going to be used for the demonstration. On the left is the Fusion hub, and on the right is the MBX. The Fusion hub is going to be used as the head-end device and connected to by the MBX. To create the tunnel, we'll start by going to the Speedfusion page on each device. We'll create a new profile on each. For the Fusion hub, we'll give it a name and the remote ID. The remote ID is the local ID of the MBX. We could add an additional password here, but for this demo, we will leave it blank. On the MBX, we will also add a name and the remote ID, which is the local ID of the Fusion hub. We will also need to set the remote IP, which is the Fusion hub's WAN IP address. At this point, make sure to apply all the changes. If the settings are correct, the tunnel will establish itself. On the dashboard, you'll see that the tunnel status becomes visible on each device. Clicking on the status button next to the Speedfusion tunnel will show further details and allow you to see the connection status within the tunnel. On the left screen, we're now going to show the dashboard of the MBX. We'll add the second WAN connection to the MBX. Once the cable is connected to the MBX, it will begin testing the WAN to confirm that it is working using the health check. After this is complete, the connection is marked as being up. The Speedfusion tunnel will then test the connection to make sure it's capable of being used in the tunnel. If it is, it will then add the connection to the tunnel. Its status will be shown in the right-hand screen. On this data screen, clicking the greater than button takes you to the Pep Vpn Test Tool where you can perform speed tests to see the WAN status and the remote WAN status within the tunnel. You can turn off each of the WANs within the tunnel temporarily to relay how the tunnel will perform if a certain connection gets disconnected. As you can see in this test, the two links give a combined upload speed of around 62 meg per second when bonded and 32 meg per second each. The ability to disable the WAN connections in this screen is temporary, and they will automatically reconnect after 15 minutes if you forget to re-enable them. At the same time, the test will affect the tunnel performance for any users that are using the connection, so care is advised when using this tool. We have now inserted a SIM card into the MBX cellular port 1. While that establishes, we'll show you a feature which was added to firmware 8. It allows you to do a point-to-point speed test between two Peplink devices. This is called the Wan Analyzer and can be found under the System tab on each device. We will tell one device to be the server and then configure the other device to be a client. The tool can be really useful for confirming the connection speeds that you are seeing in the Speedfusion tunnel, as the advertised speed of the WAN is rarely achievable due to factors such as latency, distance, and ISP congestion. You're able to test the various connections in any combinations that you choose and then easily see the amount of bandwidth that is available between the two devices. Returning to the dashboard of each device, we can now see that the cellular connection is active on the MBX. Visiting the Speedfusion status screen shows that a connection isn't added to the tunnel and that it isn't able to use the connection to send or receive data. This is shown in the cellular WAN link status. The reason for this is that it doesn't know a route to get to the Fusion hub due to only knowing the private IP address of the Fusion hub WAN. The firewall also needs ports forwarded to the Fusion hub to work as the default ports are currently in use. We have configured custom ports on the firewall which are forwarded on the Fusion hub. On the Fusion hub, we'll also set the receiving handshake port for all the Speedfusion tunnels by setting it here and saving it using the Save button directly below. Then for the profile, we'll set the custom data port for the tunnel on the Fusion Hub side. We'll save and apply those settings. On the MBX, we will then add the remote handshake port to the Pep VPN profile and add the external IP. On this side, the data port can be left default as well as the receiving handshake, as both these will be inbound to the Fusion Hub. Save and apply these settings, and then we will wait for the tunnel to reestablish. You can click the Show All Profiles to actually see tunnels that aren't connected. If the settings are correct, then the cellular connection will be used for the tunnel. We can see that status updating now. Running the Pep VPN test on this will also show that traffic is passing over the cellular connection along with the other WAN connections. Now we would like to show you what happens when the settings are incorrect and what messages and status screens will show you to help find the course of an issue. We will start by setting an incorrect remote ID on the MBX. This caused the tunnel to be stuck in starting. Checking the event log reveals the following message, which states the remote ID or pre-shared key is incorrect. Nothing is shown on the Fusion Hub side. We'll then correct the remote ID and set an incorrect data port. Again, the tunnel gets stuck in starting. Although you often see the device authenticate and then start creating the tunnel, only to fail and cycle through it again. The event log will show you that the device failed to connect to the remote peer. If the settings were correct on the Peplink device, this is to indicate that something is blocking the traffic between the peers. Finally, setting the data port and remote ID to the correct setting and removing the external IP will add the tunnel to connect but not the cellular. This status will be shown under the SpeedFusion status screen as a link failure. Thank you for watching. We hope you found this video helpful. For more videos like this, stay tuned and subscribe.